Okay, let's see if I can get this other side done. Now we're doing energy bar charts, which we just did, so hopefully that's fresh in your minds. So we've got a total bar chart here, and every point, remember that's our conserved energy that stays the same, and then within that, potential and kinetic are going to change depending on where she's at. So we want to sketch the bar chart for when she's at rest at the top of the track. Okay, so here she is at the top of the track. She's not moving, so she doesn't have any kinetic energy. All her energy is going to be potential. So I'm going to draw the same bar as my total bar in there, because all of her energy at that point is potential. Okay. Then when she's at the bottom of the track and moving quickly, now she has no height. Okay, so there's no potential energy here. She's moving quickly. All her energy is kinetic. It's all been converted to kinetic. So I'm going to do the same thing over here that I did in part A, but for kinetic instead of potential. Okay. Now, when she's halfway down the track, okay, so this one's a little trickier, but not bad. She's got height at this point. She's also moving at this point. So she's got some of each type of energy. And if she's halfway down, then they're going to be half and half. Okay, so this is 1, 2, 3, 4, 5, 6, 7 squares, which is kind of annoying. So I'm going to do 3.5 and 3.5 because I want my total to add up to the total energy. So 3.5 squares of potential and 3.5 squares of kinetic. Okay, that makes sense, hopefully. So my energy's split at this point. I've got some of each type because she's got height, but she's also moving, and she's at the halfway point, meaning this plus this equals this. Remember, that's always the case. Okay, here, this plus 0 equals this. Here, 0 plus this equals this. Here, we're adding them up because it's split at that point. Okay, how much potential energy does she have when she's at rest at the top? So remember, potential energy we calculate by using m times g times h. H is her height. Okay, so she has a mass of 60 kilograms. We're using 10 for g, and the ramp is 6 meters high. Okay, so that's 60 times 10 is 600. Multiply that by 6, that gives me 3,600 joules. How much total energy does she have when she's at rest? So remember, if we go back and look at our bar charts, total is always a conserved quantity. When she's at the top, all of her energy is potential, so that means she also has 3,600 joules of total energy, also mechanical energy. Remember, ME, mechanical energy, equals PE plus KE. This is like the one of the equations that's not on your sheet. Okay. How much kinetic energy does she have after she rolls down and is now on the ground moving fast? So again, we can go back and look at our bar chart for that one. All of her energy there is kinetic. So it's all going to be that same 3,600 joules again. Because at this point, kinetic energy plus 0 for potential has got to equal my total. So my total is the same. Okay. So these are all, these link back to the bar charts. This potential at the top, that's all the energy she has. That's equal to her total. So here's my total here. And then kinetic at the bottom, all kinetic, equal to the same total. And that's pretty much it. It's a straightforward study guide, hopefully. So, okay.